So hello my dear students. So here we will be discussing about the important questions of NEET, JEE and EAPCET for upcoming exams like NEET 2026, JEE 2026 and EAP 2026. So these sessions are helpful for all the students where I am going to cover top 15 previous year questions of NEET from each chapter like this, and this is our day 2 of this particular discussion. Okay, so like this every day I will be coming at live at this particular time, so you can join the live sessions at this time and you can use them at the most beneficial way. Okay, so and if you really like this, so you can also share with your friends too. Okay, so now let us start our session with this particular chapter, solutions. Okay, before going to this discussion, I just wanted to tell you about our upcoming NEET long term program, that is NEET 2026 long term program, which is going to be started on 1st July. Okay, so it means in the next month at the beginning we will be starting this particular batch. Okay, so in this batch we will be offering you the complete guidance for NEET 2026, as well as we are also launching JEE 2026 long term batch also. So in these batches we will be focusing exclusively on the dropper students, like those who attempted this year and but not happy with their results and their performance, and those who are really seriously preparing for the upcoming exam. So these batches are exclusively designed for those students. Okay, so here we will be completely cover all the syllabus for NEET and JEE syllabus. Okay, and the next thing is we will be also having specially designed one-on-one care interactions. So care interactions means what? See, you might be also having some areas where you are really lacking, right? So we need to focus those areas right now, because you already attempted last year but haven't got this clarity on some few topics, right? So now that is what we are focusing here. Wherever you are lacking, those has to be removed from you, right? So it means it should be clear and you should comfortable with those topics also. Then you can gain your knowledge and you can perform well in the exams, and we can expect a good results finally, right? So like this we have designed, and you know this is available in both offline and online modes, and you know we are also offering hostel facility also those who are coming for offline batches. Okay, so if you want more detailed information about these batches, just contact to the mobile number scrolling here on the down of your screen. Okay, now let us start our session on these solutions. See, yesterday we have discussed about this question, and we'll start with this. A complex of iron and cyanide ions is 100% ionized at 1 molar if its elevation in boiling point is 2.08 degrees Celsius. Then the complex ion is, see they have given 4 complex ions. We need to choose those complex which matches with the given data. So how can we do this? So just take, let me change the color. So just take the data, use the data. See, if its elevation in boiling point is this much, it means they have given delta TB. So this question is what? Based on colligative properties, especially here elevation in boiling point, which is taken as delta TB, indicates elevation in boiling point. This will be equals to I into Kb into M. So what is I here? It is Van 't Hoff factor. So this I is very important term that should be included in these colligative properties. So this I value gives number of ions present in that particular solution after dissociation or association. So I value must be known to us, then only we can identify which complex is this. And what about Kb? It is what? Abelioscopic constant, or here they given Kb value, abelioscopic constant value like this, 0.52 mole inverse Kg. Okay, and what about small m here? It is molality is mentioned. Just substitute the values over here. See, it is given as 2.08, okay, which is equals to I into, what is the Kb value they mentioned? So Kb is 0.52, right, into what is the m here? It is 1 molar solution, write it as 1. Okay, so now what we are remaining with? I equals to 208 by 52 I am writing. So just multiply 100 on both sides, you will get this. Okay. So now if you remove this, you will be getting 4 as an answer. So what is the value of I? I value is 4. So I value is 4 means, so after dissociation of these complexes, we should get 4 ions. So whenever we place these complexes in the aqueous medium, so we should get 4 ions from them. For example, if you see this, see I am keeping this particular complex in the water. So what happens, whatever the ions, whatever the particles, see here we have 4 potassium ions now, so those will becomes as 4K plus. Okay, now this square bracket is there now, so that will not lose its identity, the complex which is represented in the square bracket like this. So whatever inside the square bracket will not lose or will not get dissociated or will not lose its identity in the aqueous medium. So it will remain the same as one ion like FeCN, Cn 6 times and 4 minus here. So how many total ions we got? So 4 potassium ions plus 1 this complex ion. So totally 5 ions are there here. Okay, but how much I value we got? We got 4. 1/2 factor is 4. So this is not the one. How many we should require? 4 only. The first option if you look, so it will be giving 3 potassium ions. See, because 3 potassiums are the cationic sphere position. So 3K plus and how many these complex ions will get? Yes, 1. So FeCN6 Cn6 3 minus like this. So total ions are how many? This is 1 and these are 3. So totally 4 ions are there. So we have I value also 4. So what is a suitable answer for this question? So first option is our answer. Hope it is clear, and if you have any difficulty in understanding this, feel free to write in the comment box. I will address that query. Okay. Now what is the main thing you need to know? This I value you need to know. That's it. Okay, so by knowing this, you can do any question if they ask based on these complexes. When the given complex is given, then they will ask you to find I value. Now I am asking you, what is the I value, the Van 't factor value for the complex given like this. Complex mentioned like this. CO NH3 4 times, NH3 4 times, Cl2 and Cl. So what is a Van 't factor, that is what I for this particular complex. So tell me in the comment box, will be discussed. If you have any queries, and just answer this, and I will check that. If it is wrong, I will explain you in the comment box itself. If it is correct, then also I will support you. Okay, so don't feel scary to answer or fear to answer, just feel free to give your answers in the comment box. Okay, let's move further. Now here we have, which of the following pair of solution can we expect to be isotonic at same temperature? Tell me. This is also based on what? The colligative properties. Isotonic solutions means this comes from osmotic pressure pi. Okay, so if the osmotic pressure of 2 solutions are equal, then we can say it as isotonic solution. Okay, if it is less, then hypotonic solution, the one which is more, hypertonic solution. If it equal, you should say isotonic solutions. So for solution 1 I am saying pi 1, for solution 2 I am saying pi 2. If these are equal, then we can say it is isotonic solution. These are isotonic with each other. Now if pi 1 is greater, we should say that solution 1 as hypersonic, like hypertonic, and pi 2 as hypotonic solutions. Hope it is clear. Now good boy sir, हिंदी में क्लास नहीं होता है क्या? See dear good boy, which in the comment box, see I am using very basic English so that you can easily follow this. No issues, just follow the class, and I will be telling you with very crystal clear explanation only, just to follow me. Okay, see pi 1 equals to pi 2 means what? It is isotonic solution. Now osmotic pressure pi is equals to, now see after completing this, yes I will be taking both 11th and 12th parallelly. Okay, just follow the classes. Okay, now pi 1, see pi means what here? Osmotic pressure, that is taken as, so first of all Van 't Hoff factor I multiplied with its molar concentration into R into T. So we know what is mean by R. R is universal gas constant, here also you can take, and T is temperature. Since they mentioned same temperature, T is same for both solutions. So here I can write I molar concentration, I am saying Cm, okay. So that is for first solution C1 into S into T. Here also I C2 for second solution concentration and into S into T I am writing. See, both S and T are constant here, which are same both sides. So remove these two things. Now we just need to take I C1 equals to I C2, that's it. So if you simplify this, you will get the answer. Now what is the I value for urea? So what is the Van 't Hoff factor for urea? For all non-electrolytes, Van 't Hoff factor will be 1. See, urea, glucose, all these are what? Non-electrolyte. They won't dissociate into respect to ions, right? So its Van 't Hoff factor is taken as 1, okay? Because urea formula, I hope you know, this is how you can look into it. So C double bond O, NH2, NH2. So this will not get dissociate now, it will not give any ions in the aqueous solution, right? Therefore its Van 't Hoff factor I value should be taken as 1, because this will remains as a one single particle, whereas NaCl if we take in the aqueous solution, so it will dissociate into two particles like Na plus Cl minus, right? So now Van 't Hoff factor for NaCl should be taken as 2. Hope it is clear. For MgCl2, tell me. So whenever we keep MgCl2 in the aqueous solution, what happens? It will dissociate as Mg plus 2 and Cl2 minus now. So Van 't Hoff factor I for Mg plus 2 will be 3, because total ions formed is 3, right, from here, and for NaCl it is 2. Hope this is clear. Now take pi 1 in the, let us do these options one by one. So first option they are saying molar concentration is 0.1 for urea, and it's how much I value for this? It will be 1 for urea, and this side how much we will get? So this is 0.1 in the right side, and like left side we will see. So concentration is 0.1. What is the I value for this? It is 2. So 2 into 0.1, it should be 0.2. Now 0.1, 0.2, different concentrations now, different products now, pi 1 and pi 2 are not equal in this case. So pi 1 and pi 2 are not equal, so this is not isotonic solution, okay. Now go with option number 2, let us verify this. So 0.1 into urea, it means again 0.1 for urea, and this one 0.2 into 3 ions we are getting now, so into 3, so this is 0.6. so here also not equal values, so just remove that. So directly let us go with option number 4, so that you will get the answer. See here we have 0.1 into 1 calcium ion, 2 nitrate ions after dissociation. So total I value will be 3 here, so multiply with 3, so you will get 0.3 for calcium nitrate. For this one means sodium sulfate, so how much we will get? 0.1 concentration into what is its I value, so 2 Na plus ions and 1 sulfate ion, total ions are 3. So here also you are getting 0.3. So fourth option, both the pi 1 and pi 2 are equal, so I can say option 4 is having isotonic, right? So this is the isotonic solutions, okay. So you can go with option number 4 as your answer. Hope this is clear, right? Now let us move further. So now tell me, the mixture that forms maximum boiling azeotrophs. This is NEET 2019 question. So how can you answer this? Very easy and important topic. There are continuously 3 questions on the same topic. See 19 and see again 19 and again 20. So 3 questions you have seen in today's lecture itself based on this ideal, non-ideal solutions only. And yesterday's class also I have told you the questions belongs to this topic are very easy and you can answer without wasting your time. So look here. So how can we solve this maximum minimum boiling azeotrophs and all? First of all, you need to know about ideal solutions. So you need to know about ideal solutions. Ideal solutions. So what are ideal solutions? So those solutions, what is solution first? It is a mixture of 2 or more components, that is forms as a homogeneous mixture, right? It's a homogeneous mixture of two or more components, right? Now if this homogeneous mixture of two or more components have same intermolecular force of attraction after mixing and before mixing, it means, for example, A are the two components I have, A are the two components I have taken, okay, A and B are the two components I have taken. So now between AA molecules, there will be some intermolecular force of attractions, right? IMF I am writing, and for between BB molecules also we have some intermolecular force of attractions, right? Okay, so now after mixing them, these two separate components I am mixing, we will get a solution of AB now. Now the intermolecular forces of attractions we have to consider between A and B, intermolecular force of attraction between A and B. If all these intermolecular forces of attraction between the individual and after mixing are almost equal, then we can say the resultant solution will be ideal. What kind of solution it is forming? Ideal it will be forming, ideal solution is formed. Okay, now if the intermolecular forces are not same, so I am saying that intermolecular forces of like AB is more than the their individual forces, then I can say, see, intermolecular forces are more in AB case now after mixing now, so this will also form non-ideal. So in this non-ideal particularly it will form, since force of attractions are more here now between A and B, so the particles will come closer to each other when we compare with their individual case, okay, because intermolecular forces of AA is lesser and here it is more, it means AB particle will come very closer, therefore what happens in their volume, since they are coming closer, so their resultant volume will be decreases, the change in volume will be decreases. So that is what, they will be showing some negative deviation, right? The value will be lesser than the ideal volume. So that is what they will form non-ideal solutions, and particularly what deviation it will show? Negative deviation they are shown, negative deviation they are shown. And if intermolecular forces of AB, that is in the solution, is lesser than their individual intermolecular forces, this will be showing these are also forms non-ideal solutions only. And since intermolecular forces are less here, it means between particle A and B there is very less force when we compare with their individual existence, like between A and BB. Therefore the slight expansion takes place, so their volume, what it will become, so volume will be greater than their normal ideal solution. It means it will be showing what kind of deviation, so you should take this as positive deviation, you can write. Hope the concept is clear. Now look at this, look at this. So now here whenever water and nitric acid is mixed, see between like water here, like let us consider water as what now? So water take it as so water take it as A and nitric acid as B. So between water molecules and nitric acid molecule, so there is strong intermolecular force of attraction after combination of this water and nitric acid. Now what we know, there is strong intermolecular force of attraction between nitric acid and water now, so it means they will come very close to each other, so that intermolecular forces of AB, it means between water and this nitric acid is more when they mix together, therefore they will show negative deviation. So these negatively deviated solutions will form maximum boiling azeotropes. What they will form? Maximum boiling azeotropes, maximum boiling azeotropes. And see, when it comes to water and ethanol, so this mixture will be showing what kind of deviation after mixing these two things. So they will form the intermolecular forces are less here between water and ethanol after mixing, therefore they will show positive deviation. Now positively deviated solutions may form like what? Minimum boiling azeotropes. Remember, negatively deviated solutions will form maximum boiling azeotropes, positively deviated solution forms minimum boiling azeotropes. This is the point you should remember. Okay, now here when it comes to fourth option, heptane plus octane, see both let us say this is A and B. Now both heptane and octane, both of them are having similar kind of intermolecular force of attractions now, because both are non-polar, okay, and they are homologous to each other. It means what? After mixing also, after mixing like AB if we take, then also the solution will also containing same intermolecular force of attractions IMFs as we compared with the AA and individual BB. So therefore it will form what kind of solution? So this will form ideal solutions. Hope it is clear. So fourth option form ideal, and they are asking maximum boiling azeotrope. What is our answer? Only first option will be our answer. Hope this is clear. So based on my explanation on this particular question, I am expecting answer for these two questions from your side. See, first of all tell me answer for this particular question. Which of the following shows positive deviation from Raoult's law? So what is this Raoult's law? So Raoult's law, all ideal solutions will follow this Raoult's law. But if they are not following Raoult's law, means either they show positive deviation or they show negative deviation. So they are asking about positive deviation. It means intermolecular force of attractions after mixing should be lesser than the individual intermolecular forces of those respective components. Okay, see here we have benzene and toluene. The intermolecular force of attraction, let's write the structure of these compounds here. It will be like this. See, both benzene and its derivative like methyl benzene, both are of same kind now. So it means they will having intermolecular forces almost same before mixing and after mixing in their individual states and in their combined form also. Therefore this will be forming what kind of solution? They will form ideal solutions. Now always remember acetone plus chloroform. See here acetone plus chloroform have, see chloroform structure is something like this, no? CCl3H, and acetone will be having oxygen here. So between this oxygen of acetone and this chloroform there is slight intermolecular force of interaction, that is what hydrogen bonding we are saying, right? So this hydrogen bond leads them to show negative deviation. Okay, then next here if you see ethanol and acetone we have, so these are of different types. Okay, so you just remember with acetone any other like non-polar components are there like this. See, they will form what? They will form what? Positive deviation. Okay, so for example benzene plus acetone, so it is positively deviated from the ideal behavior. So it means it will show positive deviation. Okay, now acetone plus CCl4, what it will form? It is also forms positive deviation like this. Okay, now I am taking CCl4, I am writing. So CCl4 is a non-polar solvent. I am adding chloroform to this. So what it will be forms? It will be forms positive deviated solution. Now for CCl4 I am adding water. So what is this mixture it will forms? It is also forms positive deviation. Now CCl4 I am adding CiCl4. See now what this mixture will form? This is important. Look here. So look here. See CCl4, carbon and silicon both belongs to same group now, 14th group elements now. So respective chlorides we have. So they will be having almost a similar nature now. So this will be forms ideal solutions. What is this? It is ideal solution. So why I am saying all these things other than the 4 options also means they can ask in the combination with the CCl4 also. Okay, so option 4 is perfect answer for this. Now look into this chloroethane, bromoethane. See, ethane group is same, ethyl group is same, just they changed this halogens, chlorine and bromine. That's it now. So what makes the difference? They are almost having same nature now, polarity and everything is almost the same. So they will form what kind of solutions? They will also form ideal solutions. Hope it is clear. Now any confusion, feel free to ask me. Yes. Next. Here. Next, what about this question? Look here, what are the conditions? Always remember whenever we are mixing two components, what happens whenever we are mixing two components, whenever we are mixing two or more components, what happens? The disorderness of that particular solution will be increases now. So entropy of mixture will always positive. What? Entropy of mixture will be always positive. Okay, they are asking for ideal solutions. What I told you, it will be positive. Now delta V mix. See, if there is no deviation, intermolecular force of attractions and repulsions will be almost same after mixing and before mixing of those components, right? Therefore, delta V mix will be 0. There is no change in volume. If there is some negative deviation, so if two solutions of 10 ml is mixed, So resultant should be 20 ml. If it is lesser than 20, for example some around 19.9 or 19.5 we got, so what kind of deviation it is? Negatively deviating na, so lesser than that na, so negative deviation you say. If delta V mix is greater than 0, means it is more than 20 here if I consider for 10 ml, so then you should say it as like positive deviation. I hope the concept is clear. For ideal solution, delta V mix, there should not be any difference, it will be 0. So delta V mix should be 0. They are asking about correct one, so this is also incorrect one. So always remember, there is no change in the enthalpy. When we mix two components, the enthalpy change should be 0. Delta H mix should be what? Delta H mix should be 0 for a ideal solutions, because intermolecular forces are same now, therefore there is no change in their energies. Okay, so delta H mix should be 0 at constant temperature and pressure. So option 3 is most appropriate answer for this. And you know, delta G mix will be what? This should be negative for ideal solutions here. Okay, hope it is clear. So other 3 options 1, 2 and 4 are incorrect. Okay, so delta S mix should be greater than 0, delta V mix should be equals to 0, the next delta G mix should be less than 0 for a spontaneous process. Okay, hope all these are clear, right? Now these are the very important conditions that you can see in any exam. Okay, let's move further with few more questions. So can you identify the proper list, I mean matching from this? See, benzene and toluene, just now we have discussed. What about benzene and toluene? So this mixture will form what kind of solution? So both of having same nature na, so they will form ideal solution, so you can go with Q4. Okay, and delta G, what I told you, delta G should be negative for ideal solutions, right? So delta G should be negative, S1. Okay, and here water and methanol, and we are remaining with these two. So water and methanol of having different nature, so they will form non-ideal solutions. Okay, and oxygen is a gas which can be soluble in water to some extent, right? So what we can say, P3, so we have P3 in everywhere, P3 is there. Okay, no need to confuse with that. And next option what we have, Q ideal means Q4 is there only in one option, so go with that option. So option 2 is perfect answer for this question. Hope this is clear. Now see, R2, yes, R2 S1, yes, you can go with option number 1 as your answer. Hope this option number 2 as your answer. Hope this is very clear, right? And any difficulty, just ask me. Yeah, so now one last question here we have. Match these questions, I mean law with respect to their equation, corresponding answer, column 1 with column 2. So Raoult's law. So Raoult's law is what? So it will be used for expressing what? It's also like expressing ideal and non-ideal solutions, everything now. So now just match these two with respect to this. So what is the Henry's law? It says it gives effect of pressure on solubility, effect of pressure on solubility. See, effect of pressure on solubility. Like this we have now, P gas equals to KH X gas. Solubility is affected by what? Pressure. More is the pressure on the gas which is present on the surface of a liquid, more is its solubility. So that is what Henry's law says. Okay, the next benzene and toluene, just now we have discussed. So they forms what? Ideal solutions. Now ethanol and water we have. Ethanol and water, they will form azeotropic mixture. So which type of azeotropic mixture I want to know from you. See, I am saying here I am only giving one more option also. I am only giving one type of answer also. You just tell me based on our discussion. So ethyl alcohol and water will show positive deviation from ideal behavior. No? So now we know the positively deviated and negatively deviated solutions may form azeotropic mixture. Now positively deviated solutions forms which kind of azeotropic mixtures, that I explained just now in last 10 minutes discussion. So just based on that you just tell me what kind of azeotropic mixture is formed by this mixture which is showing positive deviation in the comment box. Okay, next that is about the matching. So Raoult's law is nothing but this one. Okay. So here, which are the following 10% aqueous solution will exhibit highest osmotic pressure at 27 degrees. So take pi equals to, what is the osmotic pressure formula? So ICMST, like this we will be taking now. So all of them are non-electrolytes, so I value for them will be 1 in all these cases. So pi equals to molar concentration into S into T. So ST are the constants here, okay, because they mentioned temperature. So temperature is particular temperature, constant temperature. So ST value will be same in all the cases. Now write the remaining thing, 10% aqueous solution. So in the osmotic pressure, if they mention just 10%, you should understood that the 10%, the percent you should consider it as weight by volume percentage. This is how much they mention as 10%. Okay. Now what is weight by volume? How can we relate this weight by volume to this molar concentration? See, molarity equals to what? Number of moles by volume into 1000 if it is in ml. So I can write weight by volume into 100 into 10 by molar mass of this solute. Like this I can write now. Yes, see, weight by volume into 100, this is nothing but weight by volume percentage. So molarity, in the place of molarity I can write weight by volume percentage into 10 into this ST divided by molar mass of this particular electrolytics, like whatever the solutions they have given. Hope it is clear up to here. Now weight by volume percentage is constant, that is how much? 10. So this is constant, these values are also constant. Now our osmotic pressure, pi depends only on what? That depends only on molar mass. So pi is inversely proportional to molar mass of these given substances. So one which is having more higher molar mass will be having what? Higher molar mass, lower osmotic pressure. Hope the concept is clear based on my explanation. Now what is the molar mass of these things you need to calculate. So higher molar mass or lower osmotic pressure. So which will exhibit highest osmotic pressure? It means it should contain lower molar mass, so that will exist higher osmotic pressure. So urea will be having how much? 60 molar mass. For ethanol how much? So just take the formula and calculate. C2H5OH means, so 1224 plus 630 and 46. So which is having least? Ethanol is having least molar mass. We know as glucose and sucrose are very large molecules, therefore they will be having higher molar masses. So which is having least molar mass? Ethanol. Therefore ethanol will be having least molar mass, so highest osmotic pressure for ethanol. Now I am asking you to arrange this ABCD in the option of increasing to decreasing order. I mean, write highest to lowest osmotic pressure order in the comment box. I will be verifying your answer in the comment box. So thank you for watching. Stay connected with us. Now you will be having continuous sessions, live sessions of physics as well as mathematics for MPC students and botany zoology for BPC students. So stay connected with us. Thank you for watching.